Dear students, previously you have studied about chemical kinetics, which tells you about the rate of reaction and the factors affecting the rate of reaction. This chapter, chemical energetics, tells you about the feasibility of the reaction, the possibility of the reaction, whether a given reaction is possible or not under a given set of conditions. Before studying this chapter, you have studied a very number of definitions like system, surrounding, process, isothermal, adiabatic, reversible, irreversible, intensive and extensive properties. And in addition to this, you will study about internal energy, enthalpy, entropy and free energy. Whenever a question is asked about the intensive or extensive property, please see that intensive property is one which is independent of the amount of the substance, whereas extensive property is one which is dependent upon the amount of the substance. Even if you confuse, just see if a property which is uniform throughout, that is intensive. Just like temperature of your body, which is uniform throughout, so it is intensive. Density of a liquid, it is uniform throughout, it is intensive. Also keep in mind that the ratio of two extensive properties is always an intensive property. Mass extensive, volume extensive, ratio mass and volume is intensive, which is density. Now the question is, which of the following is an intensive property? Freezing point, refractive index, viscosity. Freezing point is uniform throughout, refractive index is uniform throughout, viscosity is uniform throughout. It means all the three are intensive properties. Hence the answer will be 4. Then work is basically, if work is done on the system, we are increasing the internal energy of the system, so it is given a positive sign. If work is done by the system, the energy is used, so it is given a negative sign. In the same way, if heat is supplied to the system, it will increase the internal energy, it is given a positive sign. And if heat is supplied by the system, it is given a negative sign. Now if there is a question, which of the following work is done on the system? You see, work will be done on the system when it is accompanied by the decrease in volume. So if a question is given to you, see where delta N gaseous is negative. If delta N gaseous is less negative, it means that the work is done on the system. If delta N gaseous is positive, it means work is done by the system. Generally solids and liquids, they have got the same volume, so work is not done. So in this question, if we look at all the 4 examples, in the first case liquid solid, so we will say no work done. In the second case, solid gas giving you solid, so the gas is changing into a solid, means accompanied by the decrease in volume, hence work will be done on the system. So this will be the answer. Let us see the third example also. Again the number of moles are same, all are in the same state, no work will be done. In the case of fourth, all are gases and number of moles are same, so no work will be done. Now after this, you have got basically the different types of enthalpies. You see, whatever reactions we are carrying out in the lab, they are at constant pressure, not at constant volume. हम कोई pressure cooker में तो बेटे reactions करते नहीं कि volume constant रहे. We are doing it in the open container. It means pressure is constant. So certain energy is used by the system to occupy that volume. That energy plus internal energy is known as total heat content of the system. So there are different types of enthalpies which you can just go through the booklet and read the definitions. There is one standard enthalpy of formation. Whenever you are asked a question regarding standard enthalpy of combustion or standard enthalpy of formation, formation means 1 mole of the substance is formed. Keep 1 mole of that substance on the right hand side and write down the different elements present in the stable state. And then no need to balance the standard the number of moles of formation of the product. That will remain only 1. Balance with respect to that others. In the same way, when it is enthalpy of combustion, you please take only 1 mole of the fuel and then balance the equation. Don't change the number of moles of the fuel. Now enthalpy of neutralization. Everywhere we see when 1 mole of the substance react with this, when 1 mole of the fuel is burned, when 1 mole of the substance is formed. But in the enthalpy of neutralization, it is the enthalpy change taking place when 1 gram equivalent of the acid react with 1 gram equivalent of the base. It is not the mole. because 1 mole of acid may have 2 moles of H ions. So it is 2 gram equivalent. It may have 3 moles of H ions. So regarding this, you must keep in mind, it is basically the enthalpy change taking place when 1 mole water is formed from H and OH ions, or when 1 mole H ion react with 1 mole OH ion to give 1 mole water, or when 1 gram equivalent of the acid react with 1 gram equivalent of the base to give 1 gram equivalent of the water, or 1 mole of water. Now other question which you can get regarding this only is when it is a reaction between H and OH ions and water is being formed, so enthalpy of neutralization should be same in all the acids, but actually it is not so. If the acid is weak, enthalpy of neutralization will be less, not because it will not react completely, but because a certain amount of the energy will be used to dissociate the undissociated acid. Dear students, 1 gram equivalent, 1 mole H ions of the acid, whether weak or strong, will certainly react with base. Acetic acid is as strong as HCl in NaOH. So don't think that acetic acid will not react completely. That is why enthalpy of neutralization is less. It is less because out of that 57.51, certain amount will be used to dissociate the undissociated acid. Now the question is, enthalpy of neutralization of acetic acid is minus 51.1 kilojoule, and that of the strong acid, strong base, is 57.1 kilojoule. Then delta H, ionization of the acid. Even if he doesn't give you the enthalpy of neutralization of strong acid, strong base, please learn this value. The examiner may not give you. Now, enthalpy of ionization of a weak acid or a weak base with strong acid or strong base is enthalpy of neutralization of weak acid or weak base with strong acid or strong base minus 57.